So welcome everybody. Bonjour. Hi. Welcome to the stream. Welcome to All Around Azure. It's like the non-official name for a little while until we got the big thumbs up. But right now we don't mention it too much. But it is All Around Azure. So I'm Frank Boucher. I'm a Microsoft Cloud Advocate. And today with me, I have another Microsoft Cloud Advocate. Erik, welcome to the show.
Thanks for having me.
Can you introduce yourself and explain maybe a little bit of what you do, though? Like it will be very obvious in a few minutes anyway.
So I'm Erik St.Martin. As Frank said, I'm a principal cloud advocate here at Microsoft, where my focus is primarily open source and open source engineering, but I also primarily focus on container-related technologies. So I've been using Docker and Kubernetes since around 2014. I've contributed to both of them. I often speak a lot about them. So I am here to hopefully teach as much about containers to Frank and everybody here as I can in an hour and a half, though we should be aware that it can take days. We could do several day-long workshops, especially if we get into container orchestration and stuff. So we'll probably keep it light. If you've got questions about things and want to go dive deeper into a specific area, then we can certainly do more streams on how to do all of that stuff.
Wonderful. Like, I know containers. I use them a little bit. I use container like with apps. I didn't play with the orchestration, so I understand like the idea and stuff like that. So like it's perfect for me. So like you will be able to bring me further down the road. No, that's awesome. So yeah, hello everybody. We see a bunch of people joining in the chat. Super cool.
Yeah, and this is interactive from my understanding of the way Frank does these. So we sort of have an agenda, but we are happy to veer based on questions and things that people have. So I think to start off, we'll kind of just do a little primer on containers, and then we'll start looking at how we can deploy those out to Azure specifically, how we store them and retrieve them in registries and things like that, the various different ways we can run them, and then based on how we kind of ad hoc flip things, we'll determine whether or not we get into container orchestration and at least like the starting point of getting our app running in Kubernetes. Obviously, we could do several day workshop on Kubernetes alone, so we won't be able to go too deep there, but we can follow it up.
Excellent. Yes, you understood correctly, Erik. It is interactive. Like it's not just the two of us. Everybody, you can ask your question. Erik can see his also the chat on his side, but maybe he will be in the zone and he won't see it. I will make sure to bring back the question, but we might just let him finish his sentence or something like that. But then I will ask all those questions.
On my Twitch channel, I have a bot where people can do ! Alert, and it flashes all of my lights in my room.
Ah. Yeah, I saw you. I was watching you the other day and you were having fun with like changing all the configuring, I think, or naming all the lights.
Yeah.
So let's say, if people want to follow you, usually I do that at the end, but let's do it right now. So if people want to follow you on Twitch, is it the same alias, your Twitch user, than their Twitter? Because Twitter is just on top of your...
Yeah, Twitter's my full name, Erik St.Martin, all jammed together. On Twitch, I have a different one, just for confusion. Yeah, you saw me message in the chat. It's Erik and then the word dot spelled out, ERIK.DOT dev, DEV.
Yeah, Erik.dev.
Yep.
Excellent. So I'll just make sure people can find you. Boom.
Wait, I'm missing out on the background music.
Yeah,
what is
you don't
this?
Have that.
People are talking about background music. I don't have music.
No, it's only for the people, not for you. I want to keep you focused.
No dancing. I can't dance if I don't hear music.
Yeah, I need to find a way. Though I'm not sure it will be very interesting to push music to you too. But yeah, it is lo-fi music, so it's very whatever. Anyway, talking about focus. How about we get started?
All right, so you said you had a little background in containers.
Yeah, let me first switch to your screen.
but I don't know how many people in the stream here have some familiarity with containers. What level do we want to start at?
Yeah, by raise on hand,
right,
in the chat.
So, because we can go into how they're implemented.
Yeah, minimum level. Let's start just like, let's start slowly. Bring everyone with us. Like, it will be fun.
Okay, so the first thing we need is we need an app. So I'm a Go person, so we're just gonna quickly make an app.
Perfect. There's a bunch of beginner and zero and minimum level, so perfect.
All right, so we need format package. We need net HTTP. We need log. Whoa, what am I doing?
Yeah, that's a good idea, Kevin. When it's
What's
a good
that?
idea to push the app in a container, or like, seeing the scenario, the why, not just the how.
Yeah, so I guess that's our first kind of stopping point. Containers are really useful by themselves, even without orchestration. And I know we often group them into how do we solve orchestration problems using containers, but reproducible builds and using containers as a means for packaging and deployment is extremely valuable. And especially when we start getting into things like, we'll do that with this app here. We'll do multi-stage builds where we can separate the dependencies needed at build time versus the dependencies needed at runtime. And that will allow us to do CI/CD on very generic machines. We don't have sort of like dependency issues where you upgrade a dependency on a build machine for one app, but it breaks another app. So containers can be useful through that whole process without necessarily using an orchestrator.
Wonderful.
All right, so what did we say? Oh, we need net HTTP.
So I interrupt again. So right now what you are doing, it's not container related. You're just building an app so we have something to work on?
Exactly.
Okay. So it could have been done in anything. Could have been like Python, .NET, whatever, JavaScript. We just need some app, and I'm assuming it will be a website. So because it's because I saw HTTP.
What's that?
I'm assuming it's a website because I see HTTP.
Yes. So yeah. That's all we're gonna do is we just need, and because we can do this really, really fast, and then we need a
we'll let you focus on
HTTP request. All right. So this is just a function that we're calling, passing in a path, and then a function to be executed every time we get a request. And then we just need to, we need to just write something to it. So we're just going to write to that request. Hello, Twitch. All right. What am I missing? Why are you yelling at me? Oh, because our request is actually a pointer to a request. Okay. And then why am I doing string? All right, that's it. Now all we need to do is we're just going to log this out if it fails. Listen and serve. Now we're going to tell it port 80. And I believe that should be, no. It takes another argument. There we go. Okay, that's all we need. So now we have a oh, it's not in here. All right, let's go into what I call it, HTTP hello. Build. All right, and now, oh, because I'm not an administrator. All right. We'll make it 8080 really quick. We're just going to prove that this works. Oh. I suppose I could have just had this ready too, but
you could.
All right,
but that's fine. We'll let it go with that, right? chat.
Yeah, nothing like scrambling to code something on the fly. We're like, we don't really need this. All right. So,
well, like it's fine. I think it's cool because right now we understand that that part
okay.
is not really important in the topic of today. It could have been anything. Like I don't know Go. It could have been anything else. We just need a little something to work with.
Yep. So now we have this. It's just going to return back hello Twitch.
For our point of view, we just see a white screen because the display text is probably under the title.
Yeah. There we go. So
yay! Now I see a hello Twitch.
Okay. So now let's containerize this thing.
Okay. So we had a question while you were in a focus zone by Galactic was asking, are we using Docker?
Yes, we are going to be using Docker. So
Docker is just one of the tools to manage container, isn't it? Like it's just like the most popular. Is it? Am I wrong saying that?
So historically, containers have kind of existed before. Docker created like a really useful abstraction, which is what we're showing now, in creating the Docker file where you can script things. But at their primitive level, Docker containers are composed of a couple things. It's a zip file. The image is a zip file with a manifest in it that tells the container runtime how to execute this, and it has the working directory. So effectively what the container runtime does is it goes out and it fetches a zip file, looks at the manifest to figure out how it needs to configure itself when it executes, extracts that zip file somewhere on your local system, roots you into that directory, and then it uses two additional things inside the Linux kernel. One of them is namespaces, which controls what that process can see as far as, network interfaces, things like that. The other is how much of a given system resource that thing can consume, how much CPU, how much memory. Those have been built into the Linux kernel for well over a decade. Well, longer than that now, a decade probably by the time Docker came out. So Docker really kind of leveraged people used to use those things before, but Docker really created a way to easily do that. And well, all of that is wiped away when we talk about Windows containers, because a container on Windows is actually a highly optimized Hyper-V virtual machine. So you used to be able to talk about containers in a generic form. All right, so, oops. The first thing we need to do is in our Docker file, we're going to do a from line. And what this does is, you can think about when we talked about the root directory, this is a starting point. So this is as if we had a root image already, and now everything we're going to do is going to layer on top of that, continue to add more and more files to it.
Yeah. So like let's just pause for a split second here.
Sure.
So right now you are in VS Code. You don't need VS Code to do containers, right? You just a text editor that you really like. There's some extension that helps you to speed up your process if you want. But it could have been done on anything. Could have been, I forgot the name of the other, like Electron or any other text editor.
Yep, this could have been anything. We could have done it in Notepad if we wanted to.
Okay.
In fact, I would normally do it in Vim.
Oh, that's the only one I like. You know what? Like yeah, that's the only one I'm like, I know people like it, but I don't know why. Like it's not appealing to me, Vim. I don't know why. Because I know it's very nice and everything. Anyway, I don't want to open that Pandora box.
we could really sideline this.
Yeah,
this
episode. No, I don't want to. But my other point was, what the hell is a Docker file, sir? I know what it is because, like I said, I use it, but like maybe you just jump something now. Like, what's a Docker file?
Yeah, so a Docker file is just a way to define our container image that we're going to create, and every container that's running is started off of an image. So we're taking kind of think of a zip file of a very small Linux distro that you've installed. That's all zipped up. When we say from Golang 1.14 Alpine, we're taking an Alpine Linux root directory that already has Go installed on it. And now each line of this is going to create another layer, which is going to allow us to modify that root directory, and it's going to produce a new image that we're going to be able to use to run things. So
it's more like a recipe, something I will follow. Let's say I start from the spaghetti sauce of my mother. So I do that, and then I will add some spice that I like and stuff like that, and then become my spaghetti sauce.
Yeah, and you can basically think of it as very similar to, a bash script or a PowerShell script or something like that, where we're kind of automating this process. So, this line, it's like, hey, go fetch this base image. Inside of that image, we're going to create a source directory, and that's going to be from this point forward, that's the directory we're working in. This copy line here is saying I want to copy main.go and go.anything, and this is basically our go.mod file, into that source directory. And then we're going to run this particular command inside that image. So this is just a particular compile flag for Go. We're building it, we're producing a binary, we're going to put it in bin web, and then this goes in the manifest file we talked about to tell the container runtime, when I execute that container, what is PID 1? What process am I starting up? And we're telling it that's going to be bin web. There's also a command version of that, and they vary slightly in their usage. So a command is a full command that's being ran, whereas entry point, if I called docker run on this image, any additional flag that I send in would become an argument. Well, not flag, any arguments I send in past that would become arguments to this.
Okay. I never saw the square brackets before. Is it because now doing so you could have multiple endpoint or commands or stuff like that?
If you needed more parameters, you would put them here. So you probably see it without that.
Yeah, without the square bracket, probably because it was only one, and since it's optional, that's why people didn't put it.
Correct.
Okay.
Vim for life, not just Christmas. I like your style. I'm using the Vim plugin here. Frank and I were talking about this before the show. I'm on this couple-month experiment to see whether I can use Windows and VS Code as a development platform. I'm typically a Linux person, using just straight Vim and i3 Window Manager. Okay, so now we have our Docker file.
We have already a question from xgenet46. So why an entry point instead of a command line?
I typically end up using entry point myself. That's just the default one I do because I'm often containerizing things and wanting to pass arguments into them. So for this particular use case, it actually wouldn't make a difference which one you used.
Okay. And right now you are not using WSL2 inside Visual Studio Code, right?
I am not using WSL2 inside of Visual Studio Code, and I will tell you why. So
don't have any dramatic sounds here.
Yeah. So I like to run bleeding edge. So I am running a fast ring insiders build, the newest Docker preview with the WSL feature turned on, and what else? And the most recent Ubuntu inside WSL. And recently in one of the updates, if we open this up, I can type, say, Docker login, and we could let this go till next week and it won't finish. And I'm not sure which of the new things that I installed broke that. So, but typically, yes, I would be doing this in WSL.
Yeah, and I would have been really happy because, that's life.
Everything else works. We can do a Docker build, we can do a Docker run, we can do all of that, but we won't be able to log into the container registry that we ultimately...
But it works, and it is possible, and it is lovely. It just, because you're running everything on the Edge preview alpha version, something like in that mix today at this time doesn't work. So it could be fixed tomorrow, but today it's not working. So, but that's good. So we have an opportunity to run in a PowerShell environment and see that it's also working.
Yeah, and these commands would work exactly the same. Wait, did I not build that? Unable to find image. All right. 8080 again. Remind me to change this when we go to push it live.
Okay.
Well, I guess we could do this too.
Like I think I will push that on the cloud, the chat. Remember me to remember him.
It doesn't matter how long you've been doing Docker, you'll always forget which side is which.
Oh yeah, I was hoping you could help me on that, because every time I need to Google with Bing to make sure I have the good one.
Yeah. So this is we want a TTY, so any logs and things like that will just spit out on our screen. If we didn't want to, we could daemonize it. This -p is saying we want to map port 8080 on the host to port 80 in the container. So we can now prove that all of this works again. And maybe not. What am I missing?
Is it running? Did you press run?
Yeah, we are running. We are running. Why are we not working? Why are we not working?
Because on his machine right now, to expose, like the port 80 is probably busy by something else, or you need to install IIS or something like that. So 8080 is.
Let's just try it this way.
8080 will works.
There we go. So we just map 8080 to 8080.
That's wonderful.
Yeah.
Oh yeah, so, probably because your code, you expose 8080 in your code, right?
Oh, right. I didn't redo the Docker build after I changed that. That was our issue. In the code was still 8080. I didn't redo the build. Okay. Mystery solved. Yeah. So if we change,
did I solve a Docker issue? Like wow, I'm impressed.
Okay. So in this particular case, so now we've rebuilt it with 80 in there. Now we can do this where we map 8080 on the host to 80 in the container, and we're still working.
Okay. And Erik, both of us step over something, like we used the verb build. We spoke about Dockerfile, but we didn't bring the vocabulary with that, so maybe we should.
Right, so now the way we take this Docker file and we convert it into an image that will be able to run is using the Docker build command. This additional flag -t after it is how we name it. So in this case, we're naming the container image HTTP hello. The dot here represents the context. So what are we passing into Docker? So in this case, we wanted to have access to our whole HTTP hello directory, so that when we talk about copying over these files, they're getting copied over relative to this context that we're passing in.
So you build your container instance with the command build. I take your Docker file, your recipe, and build that stuff.
Oh, somebody's asking about no need for expose. Yeah, you don't have to put that in there. Many people do, because then when you're looking at the Docker file, you can get a feel for what ports are going to be bound to by things. But yeah, the thing that actually matters is when you call the container runtime to execute it, that you pass in those ports. Okay, so now we have this running locally, but this isn't any good to us running locally. We need this in production, because we spent all of 2 minutes writing it, and it's ready for the real world.
And I know I'm slowing you down again, Erik, but we created an image. Where they are? Where can I see if
we created an image?
Yeah.
And we can do Docker images here, and we can get. Oh, I've got a whole bunch here. Oh, good. They're in order. So here's our image.
So the first one.
Hello. We didn't tag it, so it's latest. There's this, and our image is 386 megabytes.
Wow, that's kind
which
of
is just ridiculous. So first, let's see if we can get that down.
So that's for image. And like earlier you mentioned, oh yeah, it's running. But how, like, there's also command to see what's running, right? So there's a few commands there. Like, let's just pass a few commands because I know, like, so for you it's natural.
Yeah. That's the hard part about doing this so long. It's like, oh, what was the confusing part in the beginning? So we could run this if we pass the -d flag that daemonizes it, and now it's just running off in the background somewhere.
Okay, like a service.
Yep, and we can do a Docker PS.
Right.
And correct.
So now by doing Docker PS,
we can see all of the containers that are running locally. You'll see a bunch here running on my system, and that's just because the Docker for Windows is running a bunch of containers so that I can have a local Kubernetes cluster. Oh. So for all of us, we can ignore those, but all it's doing is running all of the control plane components for Kubernetes inside of containers so that we can talk to a local Kubernetes cluster.
Because I ran before Docker and I didn't have that, but I never play with Kubernetes. So, okay, so we have the Docker images to see the image, so our recipes. We have the Docker PS to see the instance of those containers running right now.
We can also see our port bindings inside of here.
Yes. And if the image is not running right now, let's say it's stopped, I think you could do PS all or something like that, and like
correct.
Okay,
a -a flag will tell us ones that aren't. So here we can see that this one exited. That's because we killed it. But if you tried to start a container and it's just falling over, being restarted, this is where it would show up.
Okay. Cool.
So we talked about kind of like the value in containers. Well, right now we have this building and then we're kind of deploying everything together. So I think that what we should do first before we push this anywhere is let's trim this down. We can do something called a multi-stage build. And what that allows us to do is basically create one container that does the building, produces the artifacts inside of that container, and then we're going to copy those artifacts over into a much smaller container that doesn't need, say, like the entire Go compiler installed on it.
Okay, just the exe or what the executable, the artifact. We call that the artifact, but what it means, it's like whatever is the output, the exe, the service, the whatever, but not all the toolings.
Correct. So in this case, in the case of Go, it produces a statically compiled binary. We only want that binary. So,
so to do that, you said we need to do a multi-stage? Is that what you said?
Correct. It's called a multi-stage Docker build. So the first thing we do here is when we do this from image, we're going to name it. So as build. So from now on, we can refer to anything that happens inside this container as the build container.
Okay.
And then the way Docker works is the next time it sees a from line, that's the next stage. So in this case, we're going to do from scratch, which is an image that has nothing in it. So we don't have any Linux distro files or anything like that in it. It's not like a whole Alpine build or a whole Ubuntu build. There's nothing.
Is it something you just made up, or is this really something that exists?
No, it's actually a thing. So you can, you can
I thought you
Google
just made
scratch
it up.
Containers. Yeah, no.
Okay.
No.
Sorry. See? Okay,
so
awesome.
We can still do our copy line, except what we want to do now is we're going to pass this from flag and tell it we want to copy from the build container. And then we're going to copy bin web to, well, we'll put it in bin web here too.
Okay, so bin web, it's because the artifact was generated in bin web previously in the build container.
Correct. And this step, we put it in bin web.
So that's
we
why...
could have put it anywhere. If we didn't supply this, it would have ended up being named HTTP hello, and it would have been inside this source directory.
If we're doing node, it could be the root or the public or something like that.
Right. And yeah, so you could copy all that over. That's all we did. And now we have this Scratch container, and same thing, our entry point. Now, if we do our Docker build, and we call this HTTP hello, we'll just call it Slim for now, so that we can tell the difference. Successfully built. And now, if we look at this, we can see our Slim is, 0 bytes. That's not right.
That look very tiny.
That looks very tiny. I don't think that that's right. Living up to the name, right?
Yeah.
It's quite literally a Scratch container. We named it build. We put in bin web. We moved to bin web. Interesting. Let's try and run it. Maybe it is only a couple of K. No, because that's at 0 bytes, not 0 megs, right? Let's try it. It was 8080 to 80. Maybe I'm wrong.
Yeah, you shouldn't be doing the 8080 again.
Oh, wait a second. We still have 8080.
Oh, because you didn't kill your demonized version?
Right.
Could you explain the command you just did?
Yeah, so what we're wanting to do is...
So what was the problem?
So we're trying to run the other container to see whether it starts up, and maybe it really is just that small. But we got an error, and the error is just about port binding, which reminded me that we never shut down the one that we daemonized.
Okay, so when you were explaining me the command, you did one with the -d, meaning like it was demonized or like a service. So now you're just trying to, with RM, deleting that thing, right?
Yeah, so stop will shut it down, and then RM will actually remove it completely, because you could actually restart the container if you wanted. All right. Now, yeah, no such file or directory. That's what I thought. So why did you not copy over? Got our build.
So we have xgenerate46 that says always add a as final on my multi-stage.
The last one shouldn't need a name.
Could it be just kind of a best practice to make it obvious, or like it just...
You could, but it doesn't need a name because you don't need to refer to it.
Okay.
And that's why you're doing that. You're kind of aliasing it so that you can refer to it later. All right, why? Why are you 0 bytes? Why are you 0 bytes? What am I missing? This should have produced. Okay, we have our main.go. That should be copied in to source. And I am quite positive I built a little demo like this before. So why are you not working?
Because it's Monday.
Yeah. And I mean, everything else has been breaking on me this week too. Hours ago, I had the heat sinks and everything off of my CPUs, because that's totally what you do. So yes, that is the very same Docker file we have now. And we're going to put that in here and we're going to look at it. Wow, like word for word, I reproduced the same Docker file. That's pretty amusing. So why? Yeah, that's literally the same. Watch this work just for no reason whatsoever. Let's see. Uh-oh. Is it like a caching issue? Using cache. Well, let's see what we get. If not, we're gonna skip the cache and see, just kind of like force rebuild it. Who knew we'd be debugging? Look at this.
7 megs.
Was it a white space issue?
I'll put maybe, but yeah.
That's so weird. From the looks of it, those files were like absolutely identical. Yeah. Okay. Well, moving on.
Your machine is haunted.
It might be my machine. I've been having issues with it for the past couple days. It's either going under surgery after this or in the trash. So we'll see which, depending on how successful this is. So anyway, I just wanted to highlight this though. Using multi-stage builds to separate the difference between your build time dependencies versus your runtime dependencies can be huge. And Go doesn't have a really huge compiler toolchain, but if you were trying to compile a very large application, I mean, you could be in the gigs here and megs here. So separating these things can be really, really important.
Yeah, I mean, and you could also run unit tests or something like that. And of course, you don't want all those output and everything inside your container that you ship in production.
Right, and outside of just size, we're also talking attack surface, right? The more things you leave inside of your container, the more likely for things to have vulnerabilities and provide a way for people to get into your container. And there's also, ways that you can eventually escape the container if you know what you're doing. Okay, so do we have any questions on containers themselves? And I know we're kind of like moving through some of this really fast. I initially planned to get to container orchestration, but I'm more than happy to sit here and talk about these particular things, best practices and patterns for containerizing things, and saving orchestration for another time. Where to save the container. So that's actually where we're going to move on to after this. So right now, we just have all of these images stored locally, as well as their layers. Do we have the build there too? That's the other thing I want to point out. We talked about each line being a layer. We can see that if we try to do another Docker build on this. Where's my Docker build? You'll see here, we go line by line. Step 1, build. Working directory source using cache. So this is actually a cached layer, and we could actually open a container if we wanted to. We could unzip it and you would see nested zips of these layers, which is really crazy. So as long as nothing changed, it's able to use a cache of that layer and not have to do it again. So this is a very simple container, but you would want to order the steps such that the steps that are most likely to change happen later. That way you don't have to rebuild the entire thing.
Oh yeah, it's true, because if you can use a cache version, and if you change something in the early process, then like every time it generates a new version, so you need to do all the things. But if
right,
okay, yeah, it's true. Yeah, never think about that this way, but make totally sense.
Yeah, like you compile something and then you like apt install something after that. Well, the apt install is never going to change. You don't really want to like have to redo that. Yeah, container vulnerability scanning could be a topic all on its own, as well as a variety of other container security related things. We could get into Kubernetes security related things. Um, I I have talked about that a number of times with people with just orchestration in general. When we think about it, it's extremely powerful to have these self-healing systems and everything, but we also need to remember the power of it. I don't have much of a Windows background, but I still compare it. Container orchestrators are effectively the domain controller of most people's infrastructure now, right? If you pop the domain controller, game over, and it can be the same thing with the control plane. So we want to make sure that we don't think, oh, well, just because I put it in a container, my stuff is automatically secure.
Yeah, magic thinking, right? Put it in a container, so magically secure, and then like in the cloud, and then like, yeah, I'm
Well,
done.
I mean, so a lot of people, and this is usually because of the way we explain things, we try
Yeah,
to compare them to similar things. So we'll call it a lightweight virtual machine. Well, it's not really a lightweight virtual machine, right? A virtual machine, well, except a Windows container, then it really is, right? But if we're talking about a Linux container, which is what most people are using, it's a process on the system. If you're running PS on the Linux system, you see the process that's in the container. You don't see a virtual machine, you see Python. You see the Go binary running. You see it as a different process ID inside the container because of Linux namespaces. It creates its own PID namespace for the container so that you only see other processes inside that same namespace. That's why you get a different process ID than what it is on the host. But at the host level, it's just a process like anything else. The Linux kernel doesn't treat it any differently than any other process. You could manually go in and assign any process to its own namespace, which also gets into things like when we talk about debugging. If you wanted to do a TCP dump on your application, you wouldn't install TCP dump in every single container so that you could do it. You could use a tool like nsenter on the host, which allows you to execute a command while telling it to join some other namespace. And so we create these things, and somewhere along the line, people started equating a container to a hard security boundary. But when a process inside of a container makes a syscall, it's calling the host's kernel. There's no virtualized hardware. It's sharing the kernel with the host, which means a vulnerability in an unsecured container combined with a kernel vulnerability can lead to a compromise the same way your process running as a privileged user. Isn't this the same thing with Docker? What are we talking about?
oh, it was talking about the order of things.
Oh.
When you like in Python, order is very important. So isn't it the same?
Gotcha. Okay, so we've got all of that out of the way. We talked about caching and how you can do that. Sometimes, let's say you wanted to, let's say you knew that there were new images. Let's say we were doing a run apt install here. This is Alpine, and we don't apt install, but most people are familiar with Ubuntu. So if I say that, I don't know, ffmpeg, right? Let's say that we knew there were new versions here. You can do a Docker. This is not going to compile if I do that, but you can do a Docker build, and we can pass it a --no -cache. And this will tell Docker, I don't care. I want you to go back through and redo each step.
Make sure
and this is
doing a clean, what's the word in English? State? Like when you...
Right, because when you're talking about installing a system package, Docker has no way of knowing that if it ran apt install this time, that it would get a different version of that, right?
Yeah.
So that's how you would get around that. Is that different than requirement.txt? Right. Yeah. Docker should be ran in user mode. And, we could also get into things where, changing what syscalls are exposed to each particular container that's ran. Yeah, there's a ton of stuff. We could probably do like a several hour stream just on good security best practices for containers.
So I have no choice, Erik. We'll have to have you back later on.
So
let's continue with our scenario here. So we have a container.
So we have our container.
We have a light version of our container, just the artifact.
Right. We have our HTTP hello slim. Yep. We can actually retag this too. So if we just wanted to call our HTTP Docker tag, well, we're gonna do that here in a second anyway. So the next thing we need to do is these images are just locally. They're not useful to anybody. We need to push them out somewhere. So I already have a container registry created, but we could create a new one. It's pretty straightforward in Azure. So this is Azure's container registry.
So what?
So a container registry is a place that we can take that image that we just produced that comes up inside of that Docker image list, and it allows us to authenticate against it and push it there, as well as store different tags, or a tag would be a version, but not necessarily. You will often see a tag here, so not here. This Docker build, we really should be calling this, like 1.0.
Oh, so that's a good image. I found deny 1111. Like you said, like a Docker registry is a container registry is like a Git, but for a Docker image.
Right, but people could remove the older versions. But the nice thing about storing these things is really from a rollback standpoint, and that's another thing when we talk about containers, how valuable they are. It becomes really, really easy to roll back state, because every dependency that application needs to run is bundled inside that container. It's in its own little world, and it starts up using it. And if you had a catastrophic failure and you wanted to roll back, it would be as simple as just stopping that container and starting the old version of it, or spinning up a new container with the old version. And if you hadn't done a cleanup on the host, the container image would already be there, and it would just take a split second. No trying to figure out what dependencies to roll back on the host.
So Docker registry, there's one that is very popular also by Docker, right? The Docker Hub.
There is Docker Hub, and Docker Hub can be extremely useful, but here's what I will caution you with. You will often find containers on Docker Hub that are for projects that you want. I don't know, like let's pick on something. Elasticsearch, right? You're like, I need to run Elasticsearch. I want to run it in my Kubernetes cluster. I don't want to write containers logic for it. I'm just going to see if somebody else produced one. In the case of Elasticsearch, I do know that, their parent company actually produces them. But you'll often find, user123's version of that. People using Docker to deploy stuff is a really, really well-known thing. And in the security world, lots of people put compromised containers on Docker Hub, knowing that people will just Docker run them. So I'd caution you to at the very least, if you find an image on Docker Hub you want to use, let's open up Docker Hub. So just hub.docker.com, right? So I don't know. It's suggesting MySQL. So here we have the one that's, done by them. You can tell because it's not prefaced with anything. But let's find some random user person. Yeah. We'll just pick
this
that
is
person.
why we can have nice thing. Yeah, there's always people that, do mean things with good ideas.
When you find these you can click the Docker file and you can see exactly what it's installing. And if you don't know what that package is that it's installing, or it's using its own custom code, you can go to the GitHub. You should treat this like any library, because we are auditing our libraries before using them in our code too, right?
Yep.
Right?
Yeah, right.
Okay.
But more than that, so it exists. We could use that. I mean, like, I could be generating my code and pushing it there, so and then using my own image in Docker Hub. But if I'm deploying in Azure, what's the having my container registry in Azure, like, it gets closer, so it must be faster and everything.
Right. So there's a couple of things. So you could run your own container registry. Docker offers one. There is another one called Harbor.
Oh, I know that one.
If you wanted to run your own, and this has a bunch of cool stuff with it too, but I'll leave that as an exercise for everybody to go research later. So you could run Harbor, you could run Docker's registry themselves, you could use another person. The creators of CoreOS have one called Quay. There's a bunch of these. If you're already running in Azure, and we'll talk about a couple of other reasons why the Azure one has some benefits. What you want is Azure's container registry. So Azure's container registry will allow you to use service principals and authenticate against AAD and all of these things if you already have them. But in addition to that, they have the ability to do tasks. So you can get the container registry itself to look at your GitHub waiting for a commit, and then use a multi-stage Docker file to do the build and then store the new image for you. You can also get it to recognize when a parent container, so when we did the base image, the from line, we can get it to do a change so that it knows, well, if I push the parent and the tag applies to a child, then it also needs to rebuild that and produce a new version. So we get some of that, but as you were saying, one is you'd already be inside of Azure with your container registry. Two is the container registry can replicate them for you. So you just push the image to one endpoint and Azure will automatically replicate that image to other data centers so that it's closer to your multiple clusters and things like that.
Does it also manage with the Azure Active Directory?
Yes. So
that's a big plus also, too, right?
Right.
So I always give the example. My not currently. So I'm not shooting my current manager, but I used to have some manager. I want to have access to everything, but they don't know anything. So I was giving them read access to everything, so they couldn't break anything. So it was nice to have Azure Active Directory to do that because it's very granular.
So we have our container registry here. Creating one's pretty straightforward. Wait.
So from the Azure portal, so portal.azure.com, you click the top left plus button.
Yeah, I always hit the plus on the dashboard to edit the dashboard.
Yeah.
Always. I'm mostly on the command line. But we're going to come in here, container registry.
I think it's good to do the first in the portal because I think the portal is the by default tools when you don't know, it's very visual. You have point reference to documentation, so you fill up those little information, the name, the location, the SKU, the Windows price you want to be in and those things, and then we'll create that resource. Of course, like anything else in Azure, you have command line, and that's what you refer, Erik, saying usually you use the CLI command.
Right, so here we just need to do that. If we were inside of PowerShell here, I think I'm already there. So it'd be AZ group create, right? If we needed our group and we
so that's
call
for a resource group. Resource group are just a folder, a packet, like something you want to group different resources together.
Yep. And so that would create our resource group. Yep. Inside of Azure.
That's not related to container. That's just right. That's how Azure works.
And then here, we would say, at ACR, create -G for our group, and that would have been all around Azure. And then we would name our registry HTTP hello, and then skew. And that's how we would create it on the command line. And because I've been a Linux person for so long, I just feel more at home doing things that way.
I do both. I do a lot of script, of course, because when you repeat, like you do it like for yourself, I think you optimize.
Yeah.
Because I do a lot of demos and videos, like it's always nice to have the portal. Because also they have all those links and reference, so if people want to learn more, they just click the learn more about manage identity, and then like, oh, that's how I could add identity in my stuff. So I think both are awesome. Like at the end you have your container registry, right?
I will say that especially for Azure, if I'm not familiar with the product already, I will typically go into the portal, because it allows you to kind of browse around and see what's available, and you're like, ooh, what's identity?
Exactly.
And then you go in there and it explains this. But then after I know exactly what I'm looking for, I'm like, what's the flag for that, right? Yeah. How do I add the HTTP router or monitoring and metrics to my Kubernetes cluster? I just want to do it. I don't want to go searching for it.
Yeah, no, like in exploration mode, like for the first try, it's always good, and then like, yeah, command line. And anyway, if you're reproducing, or like it's part of your CI/CD or any process, you want to script that.
Yeah. So now what we need to do here is a couple of things. So we have our registry set up, and this is the name of it. We need to log into that, and this is the reason I have to use PowerShell, because it's broken. So we want to log into this particular server, and my username, we can come here into our access keys.
We can see your screen. You want me to...
Nope, you can see my screen.
Okay.
I'm going to tear this down afterwards. You can steal all of the secrets. It's fine.
Okay. No, I prefer asking before than, too late.
Yeah. So it's kind of funny. I was building a Twitch bot one day, and I gave everybody my Twitch client secret on accident. So, oops, I changed it. Yeah. But yeah, this one you can have. I'm going to tear down this registry as soon as we're done. So this is the easiest way. If we enable this admin user, that allows us to use the registry name as a username, and we have these passwords that we can use. But again, we could use Vault inside of Azure to authenticate. We can use AAD, all of those things. In this case, we're just going to do this for simplicity. And we're going to steal one of these. And then we're logged in. Okay, so now we're able to push and pull images from this registry. I will also say that in most registries you can create...
What and what?
What's that?
You say to pull and push.
Oh, to push and pull. So we created these images that we're now storing locally, right? But they're just sitting here. So these all came from somewhere, right? So this etcd, this is a kates.gcr.io. So this is Google's container registry that this etcd is sitting on. Well, it's the Kubernetes one that's sitting on Google's cloud. And we're going to be doing something similar to this.
Okay.
So that was
push and pull is the upload download version.
So that is typically, I think, hidden. So typically this is disabled, and you wouldn't see that. I had already enabled it, which is why it showed up. But you're right. I think even with that enabled, that probably should not be visible until you manually do that. We can roll it really quick too, but okay, so we should take notes. That really should be that way. Okay, so the next thing we need to do is we have this HTTP hello image, but that's not really useful to us. It needs to be in the format of our container registry.com, right? /app 1.0, right? Because the name of this container tells any container runtime where to go to fetch it. So in this case, we have this all around Azure thing. So what we're going to do is we're going to retag this. So we're going to call our HTTP hello 1.0.0. No, we hadn't done that yet. So we're going to rename our HTTP hello, but we're going to tag it so we can refer to it as both things, to all around azure.cr.io. Yes, HTTP hello 1.0.0. Now we can push that container all around Azure.Azure. I think we're typing Azure a lot here.
Oh yeah, you could have called the show, AAA, all around Azure.
Oh yeah. And so right now we're pushing these layers like this. And again, if you're rebuilding images that you've already built, we're pushing the big one. Yeah, we don't want to do that. We want the Hello Slim.
Someone is paying attention. Excellent. Like if I could give you points, I would.
Yeah, there's. We need a way to give people points. What's the whose line it is anyway, where you get imaginary points? Okay, so we pushed the Slim image up there. Now we're able to fetch it, and we could have done that here locally. Somebody else could. You can't authenticate with it. If you happen to steal the key while it was visible, you could now pull this, I guess. So now we really want to deploy it somewhere. And so here's the interesting thing, and all cloud providers are similar with this, is there are a variety of ways to do the same thing. So let's talk quickly about the options we have for them, and we'll walk through each of them and kind of why you might want to use one or the other. So currently, Azure has 3 main things that you can do to run containers. There's a fourth one. We'll leave that one out. But so we have Azure Container Instances, and Azure Container Instances are, you can think of it as a Docker Compose file or a Kubernetes pod if you're familiar with that. And they're really on demand, and they're typically short-lived. You'll pay more for them because they're short-lived, but you can throw them up, throw them away, all of these things, and you pay per second that they're running. And we'll do that first. Another way we can do this is if it's a web-based thing, is Web App for Containers, which is part of Azure App Service. And that will give you a lot of hooks where it'll give you metrics on the HTTP endpoints. You can do SSL and all of those things up front as part of the app service logic and not have to do it inside of your container. And we get a bunch of functionality there. And then those things, you still have to wire them together the way you would if you were running applications anywhere else inside of Azure on your own VMs or app service things. You'd be standing up API gateways or, Azure Front Door and things like that in front of it to do load balancing. So container orchestrators start getting you into a new world where you start talking about east to west traffic. How do the services discover each other? How do we authenticate services against each other? And things like that. Let's see, do we have questions or? Oh, if someone's taking pictures of the screen, rotate the key, yeah. And ideally, nobody should ever see the secret. If you can, try to use things like managed identities and things like that and service principals to communicate with things like Vault, or Vault hands things, keys to the container on the fly.
There's also a project from Clarkio, the Azure Mask or AZ Mask.
I guess I haven't seen that.
Oh yeah, you need to install that. In the Azure portal, it gives you. Let me find that. Continue. I will get back. Like it's a GitHub project. I think it's AZ Mask, and it just blur any like it works 90% of the time. So like there's few keys that will show up, but most of the subscription ID, object ID, and stuff like that will be blurred. It's AZ Mask. So let me find again the GitHub project, but it is super useful.
Okay, so if we do this from the portal, it's pretty straightforward. We're going to select our resource group. We're just going to name it. We're going to follow suit. It should be hello. We want to run in the East US region. And where is our image? It could be anywhere, Docker Hub or another registry. We can use quick start images and stuff like that too for sample Nginx's and things like that. But we have ours in the container registry. It already knows how to authenticate with it. And these are all of the tags we've pushed. So if we rebuilt this and did a 1.0.1, you would see all of them here. We want to run it in Linux, and we're going to stick with this 1 vCPU and 1.5 gigs of memory, and review and create. And never. I want to save all that stuff. Okay. If you wanted to do this through the command line, it would look like AZ container create resource group all around Azure. The name would be HTTP hello. The image would be that whole all around Azure. What did we name that? All around Azure, Azure cr.io. HTTP hello 1.0.0, and then we need a DNS label. Right, DNS name label, and this would be all around Azure HTTP. I don't know. And then we need to tell. Oh, we skipped that. We didn't tell it what port. So ports 80.
8080.
Right. Did we leave it that way? I thought we changed it back. Is it 8080? It's just 80. Okay.
Okay.
So, and that. So let's see, can we fix this after the fact? I don't think we can. Did it give us our own DNS label? Well, we have the IP address, so in theory, oops. What? The copy should not copy the word public. There we go. Okay, so this is ACI. So these are really cool for like throwing containers up and tearing them down really quickly. You might do this as like scheduled jobs or things like that so that you don't have to have the capacity on your typical environment to support things that are running, you know, for a couple of hours at night. You could fan out really wide. A lot of people use these things for like machine learning. So you could just fan out to a bunch of container instances to do all like your TensorFlow training and then just shut it all down. So that's all running there, and we should be able to look inside of our here for the one that we created a DNS label for. Did it not start up? Yeah. So here's all of our metrics for our thing running. So another cool thing that we can do.
There's a question for Master MNDO. Can these attack to network storage if I need to persist anything? Can these
yes.
attack?
Yes. So when you create these, we can't after the fact. Let's go back and we'll create a new one.
Maybe like we should keep that question for later, otherwise if we are not there yet though.
So my hosting. But yeah, so we can attach storage to these though. Where is it? But yeah, we can come back to that.
Okay.
But yes, we can attach storage to them. Okay, so what was the other thing we were doing? Oh, so the other thing I kind of wanted to show off is in newer versions of Docker, we can get Docker to talk to Azure container instances directly. And so I probably already have this here, but you would do a Docker context create, and you're going to tell it it's an ACI context, and then you would give it a name. I gave mine all around Azure. And then after that, we can do a Docker container. Wait. Now I'm trying to remember how this goes. Oh, yeah. Docker context. Docker, we need to pass in the context, which is all around Azure. And then we can tell it that we want to run a daemonized one. We're going to name it HTTP hello 2 because I think we already used the first one. And then we need port 80 just like normal. And then, the name of the image. So this was all around azure.azure.cr.io.
So good tips, people in the chat. When you're doing demos, that's why you use short name to name your stuff.
Yeah, so that I don't have to type it over and over again.
Or, if you know someone is like...
All right. So if I'm remembering this correctly, because this is really new. So this should all around, right?
And by the way, Erik, we have 10 minutes left.
Ooh.
That's awesome. It's definitely mean we are just starting a series. You're stuck with us now.
Oh. All around.
It was the first time we spoke about containers, but definitely not the last.
Docker login Azure. Yeah, and so that was one of the things we talked about too. Like you could literally do several days of container related stuff. I've given, 3-day workshops on okay, so there we go. So when we create this ACI, I'm going to give it this subscription. I'm going to tell it this particular resource group. Now we should be able to do this. And then you can see here that I am straight from the Docker command. I am using that to deploy out to Azure.
This is pretty cool.
And this also works with Docker Compose too. So you can get to a point where you could just do a Docker Compose up, except instead of running it locally on your own Docker, you're just running the images up in ACI, paying per second that they're running, and then you can just do a Docker Compose down to tear it all down, and you've just paid for the time that it's up.
This is really cool. So
we can also do
everything is
context
integrated
all around Azure. And here are all of the things I have running inside of ACI, and I'm doing all of this through the Docker command. So do we have time to do this as an app service? I think we do.
Let's push it, and worst case, we will, if we have a lot of question or something, we'll start from that next time and go in a little bit more in detail. So let's go the happy path of creating a website.
I'm missing the question. So we had cliffhanger.
Oh, just because I said we'll have you coming back. So we're ending on the cliffhanger.
Yeah, and getting to Kubernetes was a stretch, and honestly having a full episode for Kubernetes even just a touch of the basics will be extremely helpful, because especially when you start getting into administering Kubernetes versus things in Helm, and yeah, it's a whole new world. So we're gonna move this. What's our app name? Why not? We're gonna keep going with HTTP hello until it won't let us. It's not available. HTTP hello 2, because that's how we come up with the names. You just put a number after it until it works. All right, it's a Docker container. We're gonna run an East US. I already have an app service plan. An app service plan just allows us to define what SKU we're going to use for the containers and what operating system.
It's a way to define your price tag, kind of where you are,
Right.
like how many different kind of resource you want, and based on the resource, you will be charged a certain amount. So
Right.
it's a way to spread that, have a little bit of control.
So the next thing we need to select here, and I'll skip doing it on the command line, but there's command line ways of doing this too.
There's always command line.
So are we going to run a single container, or this is in preview? I've had varying degrees of success based on the specific Docker Compose, in honesty, but that's why the word preview is there. So if you try it and you run into things, always feel free to shoot an email and we can get with the product teams on fixing those. But for now, we just want a single container. It's stored in the Azure Container Registry. It's in all around Azure.
Oh, cool. You already detect that we have one.
Yep. Same thing if you do ACI through the portal, it does that. We don't have to worry about the startup command because it's already in there. Do we want monitoring? Oh, because I don't have not the right combination of things. So we'll go ahead and create that. And now, once this gets set up, you'll get to see the difference between like the way ACI does things versus if you picked a web app. Deploy. Do we have questions along the way? How much do container instances cost? That's a good question. I forget. I stopped looking after a while because it got hard to keep up with. It depends on the size of, it depends on the SKU that you're using, and it also depends on the availability zone that you're running in.
There's a few counter, like the way Azure calculate the price, it's because they have meters based on certain stuff. Let's say traffic in, traffic out, how many hours of this, how much the storage. So then when you make all those things together, it will affect your price. And also, like Erik mentioned, depending on where you're running, the price of running inside a data center. Let's say I'm living in Canada, so my data center here might be a little bit smaller. So the cost of managing that data center, it's split through the Azure consumption. So in US, the data center is much bigger in US East. So the price for resources will be lowest because there's more resources. So like, the piece of the pie is much smaller, so it affects differently. So depending on where you're running plus everything else, your price will fluctuate. Like pricing is most of the time my 2 cents when I'm talking to a client is we'll do a how estimation, and then let's monitor it for a little while, see how really it will cost. Based on traffic, there's so many different things that could affect.
This is not going to show up because of
the title.
There we go. So there we are running out in web apps for containers. So we do get some additional things though here. So we get all of our HTTP metrics on data transfer and 500 errors, number of requests, average response time. This is sort of all built in. We can obviously wire up authentication, identity. You can set up your own custom domain to point at this. You can do TLS termination inside of app service so that you don't have to do it inside your container. This is if we want to wire up VNet and things like that to other virtual machines you have going on. We have the ability to scale up. That means to change the size of the underlying virtual machine if you need more CPU cores or memory. And you also have the ability to scale out, which means to run more instances of these things behind a load balancer. So we get a lot of these types of things and some helpful debugging tools, cores, using API management, things like that. So this is really useful if the thing that you're running is like a web app or an HTTP API or something like that.
Yeah, something more meaningful than a hello world.
Oh, yeah. So the question is Azure a cloud service? So Azure is the name of the entire cloud. It's Microsoft's cloud. So Amazon's is called Amazon Web Service. Google's is called Google Cloud Platform. Microsoft's cloud is just called Azure. So Azure, the cloud, has, 200 different products for various things. And I would fail a test if you tried to get me to tell you, 50 of them probably.
Oh, yeah. I've been doing Azure for the past 11 years now, I think. And there's so many different products, and you could code in many different languages and be in a scope or data, machine learning, whatever, or IoT, or there's so it's so broad that it's
it's the same thing. I'm on here with Frank going through some container stuff because those are the things I know the best as far as technology and the product offerings. But a few weeks ago, I had a coworker on teaching me about all of the IoT products that I had never used in the 3 years that I've worked for Microsoft. So,
and double coupon, yes, there's no problem running anything Linux on Azure, of course. Right now, I think our container is Linux, right? The container we just deploy.
All of those that we have been are Linux containers. So Azure Container Instances, to my knowledge, App Service does not have a Windows offering for containers yet. It may, but last I knew it did not. Azure Container Instances does allow you to run Windows virtual machines. And recently, Kubernetes and AKS have allowed you to have Windows nodes.
Moshito, there's plenty of Windows also available, of course, on Azure, since it's Microsoft. By default, most of the time, Microsoft Windows is the first thing, but it's open. My point was, it's not only because it's the Microsoft cloud that only Microsoft tech runs in it. You could do any kind of language. We just deploy a Go thing. And many different apps you could code in PHP or other languages.
And we find as time goes on that organizations are becoming increasingly more polyglot because you're adopting things, you're trying to do something in one area, and that entire ecosystem is written in a language, so you end up adopting it, right? You may be a Java shop, but if you're doing a bunch of machine learning and statistics, you're probably also using some Python, right? All the best libraries and tooling for that space are all written in Python. So I think having available options for all of these things work. The one thing I will say about Windows containers, though, is you can't expect them to be the same size. You're not going to find a 7 meg Windows container. I think the smallest is, gigs. And that's just because of the entire operating system is needed. Windows doesn't have sort of that separate kernel logic.
And with that, Erik, we are at the end of the stream. I don't think there's anybody streaming outside, so I'm fine busting for a few minutes, let's say 5 or something like that, just to closing the loops. But I think we'll need to summarize quickly here.
Yeah. So we had two questions. Mastermind.io, which I have watched a lot of your channel. I was lurking while you were doing your container primer over the few days. What was your question? Any reasons in particular? What?
Probably why like Mosquito didn't like Linux.
Oh, gotcha. And then just want to, oh wait, what was the other one? What is the definition of a container in broad terms? Yeah, so there's a lot of people, Jess Frizzell and everybody make jokes about this, like there's no such thing as a container, right? The container is an illusion, it doesn't exist. So yeah, I refer to containers when we're talking about Linux containers as a highly optimized process. Or a highly configured process, rather, because that's really all they are. The Linux kernel sees them no differently than any other process. They're just, using different namespaces and C groups to control what they can see and how much of a system resource they can use. Aside from that, they're just zip files passed around, with really good tooling and orchestration surrounding them. The Windows world is slightly different because those are legitimate virtual machines.
That's cool. So if you can, I wish you luck, Double Coupon.
Yeah, and send Frank or I suggestions if you have questions, and we can schedule a much longer thing where we deep dive into Kubernetes. We can talk about how the control plane works. We can talk about how to write your own custom control plane components, like controllers and things like that. We can go as deep as everybody wants to. This is sort of like a really fast introduction on how to run containers out in Azure, but by no means a very depthy
We'll have you on the show every second week for the rest of your life, sir. So Erik, is it so on top of your video feed right now, there's your Twitter account. Is it the best way to ping you if they have question?
Yeah, Twitter's a really good way to get me. You can also whisper me here on Twitch, even though my username is different than it is for Twitter, or you can email me at eric@eric.dev too.
Cool. Well, thank you a lot for spending this hour and a half with us explaining the basic of Docker. I feel I feel like I learned. I knew a little bit about Docker. I learned. I feel like I have solid base, I think. So definitely looking forward to have you again on that show. It will be cool. We'll schedule something. If people are interested, follow Erik or myself on Twitter. We'll probably share that. Or if you look down below the stream, there's the About section in the Twitch Microsoft Developer, and there's a link for the schedule. So we keep the schedule refresh, and you will see the topic of the day, and you will see also other show, there. So if you're interested, you will have the full schedule, not just the All Around Azure, but all the show on this channel. Thank you all for all of us being with us this afternoon, or today, let's say today. I don't know what time is it in your time zone, so thank you again. And Erik, the last word.
What's that? Yeah. I'm just reading chat. So somebody said, something about Docker Kubernetes would be great. Yeah, happy to go into that stuff. If everybody wants to do a couple of hour session, we can go like really deep, and we can actually start tearing apart a container and showing how it actually works on the operating system, and kind of breaking down the illusion of the fact that a container is a real thing. And we can get into control plane logic on Kubernetes. We can go as deep as everybody wants. Ping me, send me your ideas. What do you want to learn? And we'll do it.
Well, thank you everybody, and see you next time.
Thanks, everybody.